Hello. Today I'm going to try to explain calculus derivatives to around an 8th to ninth grade audience, or around an Algebra 1 level. The word derivative might seem like a very mathy word, but trust me, it's only a word. To get started, derivatives really come down to one main concept, speed, but more specifically, slope. In Algebra 1, you know that 2 points on a graph make a line, and you interpret the slope of the line as the rise over run between the 2 points. Specifically, the slope between 2 points is the difference in their y-coordinate divided by the difference in their x-coordinate. Speed is basically the same thing as slope, it's just that there's a distance and time involved with speed, but slope and speed are basically the same thing. Slope is just speed, but for graphs. Notice, in speed, there is a change in distance over a change in time, where in slope, instead of time in distance, it is a change in y and a change in x. So, it is better to interpret the slope of a line as how fast the line is increasing in height, and you can interpret that as just how steep the line is, where a higher slope means a higher steepness upwards. It is important that the steepness means upward steepness, not downward steepness. Downward steepness would mean a negative slope. Understand that? Okay, good, since the next topic is going to involve what I just talked about. Notice that you can always calculate the slope between 2 points, except that they are vertical, but it doesn't matter the distance. They can be two really close points with less than 1 unit of distance, and they still form a line, and you can still calculate the slope. Well, in calculus, we extend this idea to its limit, as you'll see in a bit. In Algebra 1, you also learned a little bit about quadratic equations that involve one of the x's being raised to a power of 2. To bring an example, consider the equation y equals x squared. The graph is not labeled or exact, but this is the general shape of when you graph it. Whenever I refer to the line that y equals x squared creates, I'll refer to it as the graph of y equals x squared. But what if I asked you what the slope of the graph of y equals x squared is? Nonsense, right? In order to calculate the slope of a line, you need, well, a straight line. And since y equals x squared curves, you can't do that. Well, think about how slope relates to speed. Remember, you can interpret slope as how fast the graph of y equals x squared is changing, or how steep it is. If I picked any point on the line y equals x squared, shouldn't I be able to know how steep the line is, or in other words, its slope at that point? Unfortunately, remember that there's no way to know the slope of a line with just 1 point. It's just not enough information. We need 2 points to determine the slope. And so how are we supposed to calculate the slope of a line with just 1 point? In calculus, we get a little sneaky, and we cheat a little. Looking back at our graph y equals x squared, instead of only considering 1 point where we want to find the slant of the graph at that point, we look at 2 nearby points, and we consider the slope of a line between those 2 points. Think about it. As those 2 points get closer and closer together, the line that they form should get closer and closer to being the steepness of y equals x squared's graph at a single point, right? Well, yes, but it is important to be careful about the fact that these points never become the same exact point, or else there would be no line. The distance between the points is always a number greater than 0, but never 0, just really, really close to it. A quick detour. Just wanted to mention one quick thing. Notice how in the equation y equals x squared, y is completely determined by what you put in for x. This means that if you know what x is, you know what y is. For example, if I know x is 3, then I know y must be equal to 3 squared, or 9. On graphs, you can play around with the x variable, and the y variable will just play along with what you do with the x variable. If this is confusing, you'll see what I mean. Out of Detour, come back to y equals x squared and the 2 points close to each other. Consider the distance in x coordinate between them to have a certain value, and I'll call that value h. So h is the distance in x-coordinate between them. Now consider the distance in y-coordinate between them, and I'll call that distance k. Yes, k divided by h would be the slope between the points, but hold on to that thought for a bit. Now, I'm going to stick this point to the left in place, and notice how as I change the value of h, the value of k also changes, and pay attention to k. Just by changing h, I have complete control over what k is. So as you can see, k is completely determined on what h is. If k is completely dependent on what h is, I can express the value of k with an expression with h in it. And this is actually quite easy. Consider the x-coordinate of this point on the x-axis. To be clear, I'll name this x-coordinate x, so that it's easy to remember, and also for generality. I'll also remove the quotation marks around it in a bit. Now is a good time to mention that the reason why I have not set an actual coordinate for this point is because I want this to be general. This point right here could be any point on the graph of y equals x squared, and we would do the exact same process. Now this other point has an x-coordinate of x plus h, since the distance in x-coordinate between the two coordinates is h, right? Now we have all the concrete information to express the value of k in a different way. Remember that all points on the graph of y equals x squared satisfy the equation of y equals x squared. And if you know x, then you know y. Well, for this point, we know the x-coordinate, and therefore we can know its y-coordinate. Its y-coordinate must follow the equation, so it must be equal to x plus h all squared. Now that's horrible to expand, so I'm just going to keep it in this form. This newly found y-coordinate could be nicely interpreted as the distance between the point and the x-axis. I mean, that's pretty much what a y-coordinate is. But k is the difference between the y-coordinates, not the y-coordinate itself. Remember, this other point has to also follow the same rules, and since all points follow the rule y equals x squared, and since the x-coordinate of the point is x, the y-coordinate must be x squared. So since k is the difference in y between the two y-coordinates, k must be equal to x plus h squared minus x squared, the difference in the y-coordinates. I've gone all this way without even mentioning the word derivative, but this is where it comes in. Remember what I said a while ago. The closer the points are, the slope that they make will become more and more like the steepness of the graph of y equals x squared at a single point. For this case, the point will be the left point right here. Another way to make the points get closer is just to decrease the value of h, since making the difference between their x-coordinates will also affect their y-coordinates, and therefore the value of k. Now, sticking this left point in place, and decreasing the value of h, and therefore k, the line that the points will make will get closer and closer to just the line of a single point. We can calculate the slope of the line, right? The slope is just k divided by h, and since we know what the value of k is, the slope is equal to, brace yourselves, x plus h squared minus x squared all over h. Finally, the derivative is what the slope is equal to as h goes to 0, where h is the difference in x-coordinate between the 2 points. Now be careful. Remember that h never can be equal to 0 for 2 reasons. First of all, you still can never calculate the slope of a line with just 1 point. And also, with the expression we have now, if you plug in 0 for h, you will have trouble since you can't divide by 0. Well, then how do we work around this? Unfortunately, we will have to expand it, which is a pain, but this will simplify a ton, so don't worry. This top part of the fraction, expanding the x plus h squared, becomes x squared plus 2xh plus h squared minus x squared. Now, there's a positive and negative x squared in there, so they cancel out. Therefore, this becomes 2xh plus h squared all over h. All the terms in the top part all have an h, so if we divide each term by the h, from the bottom, remembering our division rules, we can get the entire expression from the big monstrosity from the beginning to just 2x plus h. Now, as we keep decreasing h, not all the way to 0, but close enough, this last h pretty much vanishes, leaving us with 2x. 2x is the derivative of y equals x squared. What this means is that the slope or the steepness of the graph of y equals x squared on any point along its graph is just equal to 2 times the x-coordinate. This might all seem complicated, but understanding each concept part by part will end you on the conclusion, hopefully. This same process can be repeated with other equations, like maybe try and figure out the derivative of y equals x cubed. Well, if anything, I hope you understand the grand picture of what the derivative is, and I hope you have a good day. Thank you for watching.